Hey, everybody. If everyone could find your seats, we'll be getting started here in a moment. Awesome. There's room up front if you're looking for a seat, as always. All right. Thank you, everybody, and welcome to Serverless Security Automation. I'm Will St. Clair, Solutions Architect here at AWS on our education team. And joining us today are Kim Weiland and Stephen Mealy from FINRA, who are going to be talking in the latter half of the hour about the solution that they developed at FINRA for automating security and compliance on their EC2 environment. Let me just do a quick overview of our agenda today. First, I'm going to talk a little bit about AWS governance in the enterprise, what the requirements of enterprises typically look like, the kinds of solutions that you might need to implement, the kind of requirements you have, and then the key configuration and control points that you need to administer in AWS to meet those requirements. After that, I'm going to do a really brief recap on serverless computing using AWS Lambda and AWS step functions to go into an example of a solution based on how to integrate these tools to automate and respond to events in your environment, as well as how to deploy a configuration baseline across multiple accounts in your enterprise. Afterward, I'm going to hand the floor over to Kim and Stephen, and they're going to talk a little bit about this solution that FINRA developed for automating compliance at the workload level for their authentication. So let me start by talking a little bit about AWS adoption patterns in a federated enterprise. I'm a solutions architect on our education team, and in my time at AWS, I've worked with a lot of higher ed institutions, which are unique because they're very highly federated organizations. You know, there's lots of different departments and teams and sub-institutions with different budgets and different requirements, and they're all operating somewhat autonomously. And what we saw is that a lot of these institutions were very early adopters of AWS. And so they take their grant money and they take their departmental money and they start working on individual workloads and building up their own environments to their standards. And at the same time, we started seeing central IT departments at these institutions start establishing a more formal framework for governance and deployment of AWS. Oftentimes, this took the form of what we would call a virtual data center, some sort of environment that looks and feels like a managed data center environment, where they can deploy their applications, have the same security zones that they have on premises, and deploy that way. And so what we look for when we work with these customers is figure out, we need visibility in what's going on in our AWS environments. We can't just let everyone go off and do their own thing and then also try to shoehorn their workloads into a more formal structure. So we need a governance approach that takes into account the IT department's overall responsibility to protect data at the institution, and but also scales to all users of on AWS. If you look at the typical university campus, a lot of the workloads aren't that sensitive, and the agility and the control is very necessary. But we still want to retain visibility into it. We don't want stuff to go totally under the radar. We also want to enable the use of the entire AWS platform. We don't necessarily want people to be trapped in a box where they have to get everything approved via tickets. One, because it sort of robs you of the same agility and flexibility that you may have sought by going to the cloud in the first place. But two, because people are going to want to do it anyway. And when they do that, then they tend to go rogue, and it deprives you of any visibility. Anyone who's had to sort of pull procurement card reports to figure out who in a particular institution is using AWS, I think, can attest to this pain. You want to be able to have visibility and then apply an appropriate level of governance. And so the approach that we typically recommend customers take is to tailor the governance and automation in the environment to the impact level of the particular workload. In this case, I'm sort of rounding up to the AWS account level. Each one of these boxes, you can think of think of it as an AWS account, proportional to size or spend. So if you look at the various axes of impact that your organization might have, the very largest accounts with the most management, maybe the most automation, most logging, most third-party tools are going to be those workloads with very high requirements for confidentiality and very high requirements for availability. You don't want those accounts to be subject to unapproved changes. You don't want those accounts to be have insecure configurations, and you also need very high visibility into what's going on. But often building that automation is, even if you use some of the techniques I'll describe in a little bit, can be very heavyweight. It's not necessarily something that you want to apply to an undergraduate who's hosting a website or working on open access data or something like that. And so The important thing is to automate the creation of accounts and then apply an appropriate level of governance that allows you to bring everyone in under your governance program without workloads that don't require it having a really high level of, really expensive level of governance. And so, general best practices, for all workloads, one thing I recommend all our customers do is establish infrastructure to, build a, AWS account basically, as a service. A user at your institution can go to, central IT to have an AWS account provisioned. At that point, they, have a discussion with, the security officer on what sort of workload the account will have, and then what the charge, charge code is to, bill it back. And everyone should be parsing your cost and usage reports in order to enable that charge back. The main reason for this is you don't want users to go rogue. You want users at all levels to be able to go to central IT, have an account provisioned, while you still retain visibility into it. And then for high impact workloads, you start talking about how do we do our medical research with PHI, or even just standard personally identifiable information. You have a set of controls that you need to apply to those environments, and you have an automated way of deploying those into those accounts when those workloads come up. And so there's various partner tools you can do, but it's also very helpful to be able to build custom automation, particularly if you have particular special requirements. So what are the key configuration points when you first set up an AWS account? There's a few manual ones. I like to throw these in there just because I want to make sure that everyone understands they're manual and both mandatory. Root MFA, when you first create a new AWS account, make sure that you have a hard token for that root MFA and that your security team is keeping those in a central locked place, that you have a physical root of trust for the security there, and that you are can create access logs for that manually. The other thing, always make sure that you set up your alternate contacts and security questions. But most of the rest of the configuration you can automate. When you talk about what you need to do to set up a new AWS account, we have a great guide on the website now called Secure AWS Account Setup that talks more in detail about the kinds of things you'll want to set up. But the key points are enabling access logging with AWS CloudTrail, deploying a standard set of IAM principles and managed policies into the account, potentially installing AWS config rules, collecting the contents of config snapshots, enabling any CloudWatch events you might, which I'll talk about in a second, and then deploying your standard network configuration. If an end user is coming to you, they might need an account provisioned with a particular network subnet. We highly recommend that you centrally pre-provision the network subnet they need with any direct connects or VPCs in advance, and then lock that down so that the end users of those accounts do not have access to them or have access to change them. And built into all this is we can use AWS CloudFormation to sort of automate this. So if you're not familiar with CloudFormation, to give you a really quick recap, CloudFormation allows you, rather than sort of plugging away at the console, one step at a time, allows you to write a declarative template, a JSON or YAML template that defines the AWS resources in your account. So in this case, I'm just defining a couple IAM groups, administrator, security auditor. These both reference various IAM policies. But you can use CloudFormation to deploy all sorts of logic. You can use it to enable CloudTrail in an account. Highly recommend that. Deploying your identity and access management rules, virtual private cloud configurations. Anything that's particularly static and needs to be standardized across accounts, highly recommend using CloudFormation to manage this. Within your AWS account, I mentioned IAM roles in particular. You'll want to standardize the roles that you're deploying, particularly if you're using an identity management tool that allows you to federate into the AWS account rather than creating individual users and groups. You'll want to have a set of standard roles. Administrator is a common policy that we see customers have. This has everything, so you'll probably want to have a constrained administrator for your organization. Security audit's another one that allows read-only access. You may define different roles, job-based roles for your organization. And the other thing is you can assign a user multiple roles through your identity provider. So if someone is occasionally going into the account to perform some sort of administrative action, there's no reason that their day-to-day looking at graphs, checking configurations should be at that administrator role. they should be going in with a read-only role, and then similar to using the sudo command in Unix, they can assume the administrator role when they need to take that action. Great thing about that is that it provides really great signal in your logs. When you're looking at your logs, you know that read-only stuff is read-only, and if you have an administrator assumption, or assume role, then you know that you can, that you should be expecting that either in a change management ticket or a manual approval, and can correlate those two activities. AWS config, another thing you'll want to collect and standardize across your accounts. AWS config creates configuration snapshots, which are JSON documents, basically describes the state of the environment. If you think about access logs or CloudTrail logs as giving you a play-by-play of what happened, config tells you how it was. So very useful, particularly in performing forensics or performing cross-references to the resources in the account. So how do you manage all of the configuration points in your account? Most customers start by doing it manually. You create a new account, you click buttons to enable CloudTrail, you go to the console and add users, you go through, you create security groups, and this is great, but it's hard to scale, particularly if you have a lot of users at your institution or organization that are coming to you and they need AWS access. And you maybe do things for some users but not for others, or maybe they already have AWS accounts. You don't have a good standardized way of doing it, and it's very time-consuming to do this. And so the next step that most customers take is using the configuration, the command line interface or the SDKs. I can write a script, and I can run this script, and it's going to do everything that should happen to a new account. Turns on CloudWatch, turns on CloudTrail, turns on AWS config, sets my standard security groups, does all this stuff. But at the end of the day, it's one, can be fragile depending on what tool you're using. Sitting on your machine, you have to create credentials to run it. It might be checked into source code, it might diverge. But what if you could host this instead of on a server, instead of a physical machine, build these as automated modules that actually run in AWS, run in the cloud, without servers, and are composable. So if I have a library of functions, maybe one turns on logging on an S3 bucket, or maybe one queries the state of a RDS instance. What if I could build a library of security functions and then recompose them as necessary to implement workflows? So that's what I'm going to talk about today. AWS Lambda, quick recap if you're not familiar. AWS Lambda basically allows you to directly run code in AWS. So if I have a Python script or a Node.js script or a Java jar, I can package that up in a way that AWS Lambda can execute directly. I never see the server. And then the execution is a build per tenth of the second, depending on how much RAM you need to run your function. The nice thing about it is that it's fully managed. You can have something that runs every hour, have something that runs every day. You don't have to spin up and tear down the server to run it. And then we also automatically scale it on the back end. So you can have hundreds or even thousands of functions running concurrently. And the sub-second metering makes it really useful for these sort of glue or administrative code functions. But I can do that for a single function. How do I coordinate multiple functions? Until recently, you had some ability to do this with simple workflow service. But we have a new offering that makes a lot more sense and is a lot, in my opinion, more fun to work with. And that's AWS Step Functions. What AWS Step Functions does is that it gives you a interface in the console where you can define a state machine declaratively using JSON. Then it builds this nice graph for you that shows you, what the steps in my workflow look like. You can define decisions. You can define wait and retry states. And then you can define tasks that are Lambda functions or functions running on a separate server. And then those tasks accept input, you perform some sort of action, and then perform output. And you can pass that output along the chain to different functions. So you can build arbitrarily complex automations and workflows that can help you automate really key components in your security environment. So instead of having a script that does something, you can automate it as a workflow and then make sure that it's always run when a particular event occurs, or every night run this workflow. And so the first example I have is, how would I do this? Let's say I want to enable access logging every time someone creates a new S3 bucket. Access logging is a really useful feature, and particularly for forensics or just figuring out what's going on, who's accessing files in my bucket. but you do need to take care to turn it on every time you create an S3 bucket. So what if every time someone calls create bucket, I have a workflow that runs and just turns logging on? So in this case, you subscribe to the API call. In this case, it would be create bucket. And then that's available through CloudWatch events. CloudWatch events can send that event to an SNS topic. You can subscribe to it from there from a SQS queue, or in this case, we're going to use a Lambda function. And this could be anything. I mean, this could be, maybe you want to be alerted when someone, creates or modifies a, particular security principle. Maybe you want this to automatically cut a ticket in your Jira. A lot of possibilities here that are easy to program. So let's say we have two AWS accounts. I have on the left-hand side, I have our managed account. This is, the actual account for the workload, and on the right-hand side, we have an administrative account that we've set up in order to perform and run some of these workflows. On the left-hand side, we have representation of the S3 endpoint for that environment. So let's say someone calls create bucket. This is going to create a CloudWatch event, which is going to immediately publish it to an SNS topic. And then let's say we've set this up in advance and that we have a Lambda event handler in the consolidated account for that SNS topic. From there, what we do is, that could be arbitrary code, but in this case, we're going to use it to kick off the remediation workflow, which is a state machine and step functions. And so that remediation workflow references multiple Lambda functions. So the first Lambda function we need is we need to get into the destination account. We're looking at the input, and we can see that, account 1234 has created an S3 bucket. And so I know that, I have a role in this account, and I need to get the temporary credentials to start working in that account. So first thing I do is assume the supervisor admin role in the target account, and I pass that along to the next step in the workflow. And the next step in the workflow is going to call get bucket logging on the S3 bucket we just created to see if a bucket logging configuration has been enabled. In this case, it's a brand new bucket, and it hasn't. And so we want to go ahead and enable bucket logging on it. And so that's the third state. Third Lambda function, we have a decision state in there that's deciding whether or not to take action. We invoke the third Lambda function, and now we've updated the bucket logging configuration. This is a really simple example, but it shows that you could implement this. You don't need to run this on a server. You don't need to sort of lump this all into a big Lambda function. You can break up your logic into its individual components, and then just modify the workflow. And let me give you a second example. Let's say that we have a library of CloudFormation templates that enable common functionality. As I just mentioned, you always want to make sure CloudWatch or CloudTrail is enabled. You always want to make sure AWS config is enabled. You want to deploy your IAM roles. But I have permissions in one account, and I want to go into another account to deploy or upload a CloudFormation template. What I really don't want is to have an administrator with a laptop that has credentials for all of the AWS accounts in my organization. That is not a good practice, and it's not one we would recommend. And doing this allows you to keep all of that running in AWS in an environment where the end user or the administrator does not have direct access to credentials or does not have direct access to credentials that can assume a role in these other accounts. So this is a little bit safer and easier to audit than it would be to try to automate this on someone's machine. And so in this case, we have a library of CloudFormation templates, and we want to automatically deploy or update a given template in the target AWS account. This is a little more complex of a workflow. We have our administration account at the top and our managed account at the bottom. An IAM user kicks off update managed account, which is going to invoke a simple step function state machine. And then it's going to assume our cross-account role, call it a Lambda function to apply the template using those temporary credentials. And it's going to sort of loop on check template status in order to prevent the workflow from finishing before we've actually confirmed that the template has been deployed. And so this is actually an example of what this state machine looks like. Unfortunately, we don't have time for a demo today, but I've written this before, and what it looks like is at the very top, we have our assume role. We then go get the existing stack information. We choose a stack action, which is actually a decision state. It detects in this case that no stack existed, so it goes down to create stack. Then we sort of wait on if the stack is in an intermediate state, wait for that state to change. Loop again, get the stack status. If the stack is done mutating, then we know that either the deployment succeeded, which in this case it did, or it could need to delete the stack and start over, or we could just declare that the update failed. And so this is just a summary of the sort of things that you can do at the platform level for your security. And now I want to turn the stage over to Kim Weiland and Stephen Mealy from FINRA, who are going to talk about how they automated security on their EC2 instances themselves with FINRA Gatekeeper.
I'm going to go ahead and start this off. All right, welcome. What I'm going to go through today is how we solved one of our problems that we had. Like many people here, I think compliance is really important to us as well as security. And we have a lot of governance that we have to account for in our environment. And so a couple years ago, as we started moving our environment away from traditional data centers and moving into the cloud, we had a couple of key goals that we wanted to keep in mind as we made the transition. And we knew that we were going to need to change our compliance and our governance processes in order to come along with us. Some things that we really wanted to make sure that we did, we wanted to maintain, obviously, the integritance of the governance. In this case, I'm going to talk about access management. So we need to make sure who has access to what servers, what they have access to, and making sure that it's approved and applicable for their job and position. We obviously wanted to do transparency. This allows everybody who needs to, whether it's an audit and compliance, whether it's an operations, or even a development community, know who is in there, and they all have access to the information and the data. Access controls are really important. We have internal workflows, internal approval processes. Every organization is a little bit different, and we knew we were going to have to accommodate for these kinds of access controls in the environment. And following the DevOps methodology, we wanted it to be as self-service as possible for the people who needed to use it. Traditionally, access management within a traditional data center took quite an amount of time in order for it to get through all the approvals. It was typically a paper process resolved around tickets. Once the access was there, it was pretty stable. Moving to the cloud, we knew these platforms were transient. So we didn't want to get into a situation where you spend 3 days to get an account on a Unix box that may be up for an hour, because you have to repeat that process every time that EC2 box comes up again. So modifying the way that we did this compliance to accommodate transient platform and still keeping all of these goals in mind. So the approach that we took, again, we wanted to make sure that it was timely and responsive. We knew that some of these machines were only going to be up in terms of hours, so we needed to be able to accomplish the goal of giving and granting and approving access in that same time frame. We wanted it based on our traditional group membership. We have a very embedded ADU organization where all of the traditional departments, approvals, lineage is there, so we wanted to be able to leverage that. Automation is key in order for it to be repeatable and for us to be able to sustain it. So that was definitely a requirement for this. The one key difference, though, is we are going to move to temporary accounts. So traditionally, instead of getting an access to an account, it takes a long time, and then that account usually stays until some kind of departmental action or server action is taken in order for that access to be removed. What we're going to go to instead, and what we'll show you what we did, is under the assumption that the access can follow a very natural approval system. It's based on the permissions that people should already have, and if it is required over and above that, then it will go through an internal approval process, but it is temporary, which means that at the end of the day, when all of the audits are due and people need to reassert who has access to these servers, it's a much smaller set. Most of the access goes away on its own naturally, and that none of that reattestation ever has to happen. It is completely auditable. We know who accessed what server, how long they had access to, why they accessed that server, and it can be connected to our internal tracking system so that if they need to track it or ticket it for operational purposes, they have that as well. And in the true DevOps methodology, we want to discourage access to servers directly anyway. This is one of the transitions of going to the cloud. If the full automation is there, the servers are transient. Making a change on a server operationally to fix something is of no benefit to the application or to the automation or operations after the fact. So we really want to start to discourage people and our developers, our validation, our testers, as well as our operations for ever needing to get on the server. Typically, we can fix it, redeploy it, have it through our pipeline in a shorter amount of time than we can actually access the server and fix it directly. In a sense, I'll go over. Down is that one?
Yep.
Not that one. No. Arrow.
All right. Hi, everybody. I'm Stephen Mealy. I was one of the principal developers on the Gatekeeper application. So what I'm going to do is, I guess I'm going to give a little technical overview on how we solved this problem. So what you see in this slide here is an SSM document. And with this document, this is an example of how we would create a user. For this document, this is using an Amazon Linux-based AMI. So this is not unique, as we have other SSM documents to support our other systems. Like, for example, we have Windows, and we have Windows systems, and there's also, I guess, other Linux operating systems that we can support. These SSM documents are staged on multiple accounts that are supported by our company, as well as VPCs. So these documents are called by the Gatekeeper tool to create the user when it is ready to grant access. To do that, this Gatekeeper application will pass multiple parameters to this document. For example, the name of the user, their public key, and their the username that they're trying to do. So with that, Gatekeeper will run this on a box that has the SSM agent running. If the SSM agent is not running on these boxes, Gatekeeper will not let you run SSM on these boxes. So if you wanted to use Gatekeeper within our organization, you need to make sure that if you're not running our standard company AMI, that you have SSM agent installed. Now, this document is just an example of what runs when the user's temporary access period expires. So when this expires, the Gatekeeper application will take the username from that particular request that just expired, and it'll revoke them from the system. As you can see, it's just simple bash commands. So when it gets invoked, it runs these commands on the box, and if it was successful, it'll return a successful message to our logs. If it's unsuccessful, it'll retry multiple times, and if it was not successful to revoke the user, we'll actually email our operations center to make sure that the user was actually removed or that this instance didn't cease to exist. There's usually a case where a user will get temporary access to an instance, but they'll tear down the instance because they needed to redeploy. So that's kind of what we try to remove the user multiple times before notifying ops teams.
So what we did was we did a solution with the SSM control documents. And SSM was great because it allowed us to incorporate one of the AWS services that we knew was going to be managed, and we didn't have to manage it. In addition, it is fully integrated with all of the IAM controls. So we can lock down these SSM documents either by account, by IAM role, by application, or even to make sure that just the Gatekeeper doesn't use it. It also ensures that any users who may need custom documents for their custom applications, we would have that ability to incorporate that as well. We are able to use our own secure password generation and distribution, so the key tokens are done at the time, emailed securely and within all company policies, so we are not reliant on any of that. We can integrate it for whatever we need. And we're able to limit it only to our own internal destinations in order to keep it within campus, which is one of our requirements. It also ensures that every user that we do have to create, when we have to create them, is done so in a compliant manner. So all of the user creations will follow our user compliance requirements as well, and that way we're not dependent on any one engineer logging in there and making sure they have it done. With automated removal, again, this makes whatever auditing is left to hopefully be a much smaller set, and it will reduce the amount of times of that audit cycle to happen, because naturally these users are either removed naturally because the machine went down, or because they are moved internally within our AD groups, and therefore will no longer have the access that they previously had to get to the boxes that way. It is based on tagging of the EC2s, so it is also aware departmentally what servers are associated with what people based on those tags, and will have the appropriate access rules according to that. And then we're able to keep this all integrated with our current enterprise firewalls. Because SSM is done within the VPC and the SSM agent, as long as it is enabled in the AMI, as Stephen mentioned, all of our existing firewall rules and everything that we need from a security for desktop firewalls still hold true. I'll let you do it.
So now I'm going to go over on a high level how the Gatekeeper system works. So the user will first hit the Gatekeeper application through their web browser. And the Gatekeeper application is just JavaScript application. We chose Angular as our framework for this. So what they will be able to do is they'll be able to search all the EC2 instances that are available in all the FINRA accounts that we have set up with the system. So they can search in development environments, QA environments, production environments, or any kind of other sort of production environment. So we can have multiple production environments. And what you can do is you can search for the EC2 instances based on like a tag value. So memberships, when user hits the application, is determined based on like our Active Directory and like their groups that they're a part of. So they're able to search for stuff that they own, like that's part of the projects that they work on, and they can select as many instances as they need to get temporary access to. One thing that the user can also do is not only can they request access to themselves, but they can search our Active Directory system for other users within the company to get temporary access as well. Because sometimes it takes multiple people to like try to sort of get into a box and see, hey, what's wrong with our system? So they can go and do that. And then once that's all said and done, they want to choose how many hours that they can go to request access with. And after we have all that information, the system will determine whether there needs to be external approval. If the user is requesting, for example, for an application or an instance that they don't particularly belong to, so it's like another dev team's project, then they will be required to get external approval from one of the members in our approval group. Also, if it's like a production environment, it's important that we monitor like who gets access to the production environments. So if they are not the member of the right group, they usually require outside approval. Once that's done, Gatekeeper will go and store the request in our database. So we just run a RDS Postgres database, and that's kind of how we monitor like and track who got access to what and when. It also helps us like in terms of like support, so we can see like if there was an issue, we can kind of go back and see when they requested it and like why. Once we determine if they need approval or not, or the approval button is clicked, Gatekeeper will take the information stored within the request. So there could be one-to-many users in the request. There can be one-to-many instances in the request. And what we'll do now is we'll call the SSM document for each instance with all the users. And SSM will run this that create shell script to create the user on the instance. Once that is successful, the users are handed out the private keys so that they can connect to the instance and get what they need. Oops, my bad. Sorry, guys. So now I want to talk about what Gatekeeper uses, how like it's set up. So Gatekeeper, we have separate hosts on the UI code, and we have separate hosts for the backend code that kind of runs the requests that search EC2s and call SSM. So we chose this because now we can keep our deployment of our UI code separate from our deployment of our backend code. Now this helps us because if we have some sort of like issue, we don't have to worry about like rebuilding the UI, or we don't have to worry about rebuilding the backend. So it allows us to keep the system up while we like deploy up another Gatekeeper EC2 instance. In front of our setup, we have ELBs. So our UI has an ELB and our backend has an ELB. And behind the ELBs are the applications running in autoscaler groups. In case we actually need the extra bandwidth, and especially for prod, it's important to have high availability, so we have multiple instances running on that environment. And so Gatekeeper is set up on one account, and it uses Amazon IAM role services to assume into other accounts to call SSM Documents should an access request happen on another account. So that's very important because it allows us to sort of run independent of whatever account, and we can add accounts without having to like redeploy the instance. So we don't have to worry about redeploying every time we add a new account. We can just update our store for supported accounts. And as I said, we basically call RDS to store these requests. So we have a I think it's like a medium-sized Postgres database that stores all our access requests.
All right, so just kind of in summary, I think you can see why we use SSM Documents. It helps because, again, it's IAM role-based. We can do it across account, which helps us also limit the footprint that we need in order for the compliance. As Stephen mentioned, we do follow an approval process. It is all AWS tagged and formed, and the way that we have implemented in Gatekeeper allows that approval process to vary, whether it is by department, whether it is by tag, whether it is by environment, or however we want the account set up. So it allows for a lot of granularity in the approval process that you want to follow with this. It is also security group bounded. So in addition to the multi-layers of security that we have, whether it's IAM, whether it's the approval process that's built in, and the fact that the accounts are only temporary, security groups are also involved, which add even that extra layer to make sure that there is not access coming from an SSM document execution from anything other than Gatekeeper if it needs to be. And it again allows our organization to stay tied to our firewalls security that is required within the organization either way. Make sure. From a DevOps perspective, it is self-service for delivery teams. So this was really important to us. It isn't available. When we built this, we made sure it was available in all of our environments. So developers can use it to get to the development environment. They can use it to request access to the QA environment. Depending on their membership or their role in the organization, they may or may not get it. And in the event that it is needed for production, it goes through an approval process and evaluated. So in the extreme emergency that somebody does need to get on a production server, it does allow for that. It is very quick turnaround, and the immediate feedback needed for the teams makes it very effective in its use. It also allows us to secure the PEM file. So a lot of dev teams, when we started on this journey, used the PEM file, and that's how everybody liked to get to the box. It was easy, they could keep it locally, but that PEM file got around all the places to all the dev teams in the environment. And we really want to secure that PEM file. We want to make sure that we rotate them when we need to, that we can change them when we need to, and that they're not, lost out there somewhere. So this allows us to secure the PEM file. We no longer need to give this out to groups. It also gets us out of the business of individual key management. Because our keys are temporary and the access is temporary, they're generated every time, we don't need to manage user keys. So I don't have people coming saying, I forgot my key, here's a new one, can you please register it for me? We just generate them every time, and we make sure that it's easy to be generated, easy to be obtained, and they can get it when they need it. It also allows us to do automated offboarding of our fleet. When an instance goes away, there's nothing special you need to do. The fact that our app, the Gatekeeper control, will query at the time of the request. So we don't have old instances that may not be up anymore. We don't have asset lists that we have to maintain as they come in, and we don't have to onboard people every time new servers come online or even new accounts come online in that sense. And it still gives us the full audit trail and reporting that we need for our compliance and our governance process. And it actually makes it a little bit easier to get through some of those reporting requirements, because not only now do we know who had a box and why, but it's immediately listed with the reason why at that time, which allows us to do some analysis on why people are getting on the servers as well. And it's a lot more detailed feedback than we ever had before. Just to wrap this up, I know I was asked if there was anything else we were going to do with this. We are also looking to expand it to RDS, again with the methodology of temporary access if needed. It doesn't quite use SSM, but we are going to extend that same kind of self-service temporary access instead of the long-term provisioning as well within RDS. That's it.
Thanks, everybody. We'll be around for a little bit by the side of the stage if you want to come up and ask any questions. And as always, please remember to fill out your speaker evaluations and enjoy the reception this evening.